We're interpreting the meaning of a derivative in context. Okay, we're going to have more application problems. You have to be able to make sense of all of this stuff. Shh. You have to be able to pull out what you need out of the question. You have to be able to write and explain yourself correctly without leaving out important words, right? So what we know some things already, right? We know that the derivative of a function, f, at a particular value represents the instantaneous rate of change at x equals c, right? That's what the derivative is telling us. To interpret the meaning of the derivative in a particular situation, it's important to include the following. What is changing? When is it changing? And the units that are involved. Okay? So let's look at number 1. Water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function. Okay, so if it tells me it's differentiable, what else do I automatically know about it? It's continuous. If it's differentiable, it's continuous, and you have to have, but it doesn't work the other way around necessarily. Okay, for W from 0 to 24, okay, where T is measured in hours and W of T is measured in gallons. Okay, and it says hours and gallons here, but we have everything's in hours, everything's in gallons. The values of WT at selected values of time are shown on the table below. So this says, using the data in the table, find W of 8, using appropriate units, interpret the meaning of your answer. Okay? So what is W of 8? 221. 221 what? Gallons. Okay? All right, so let's think about what this means. What does the 8 represent? Hours, right? It's the time. So so this is what this means right here. At T equals 8 hours, what do we know at T equals 8 hours? Well, okay. Is it producing? That's a good question. So it says water is flowing into the tank over a 24-hour period. The amount of water in the tank is modeled by this function. So this is the amount of water in the tank at this time, right? So at T equals 8 hours, there are 221 gallons of what? Water in the tank. Okay. So let's look at this. Remember, it was the what, the when, and the units involved. The what is the gallons of water, not just the gallons. The when is the T equals 8 hours. And then the units are the hours of the water. Okay, does that make sense? Okay, so we have to be specific. You can't think, careful with like it and so forth. All right, so let's look at B. It says use the data in the table to find an approximation for W prime of 15. Okay, so 15 falls in like right here, right? Show the computations that lead to your answer using appropriate units. Interpret the meaning of your answer. Okay, prime. What does the prime tell us? The flow, the rate, right? It's your rate of change. Your derivative is your rate of change. So if I want W prime of 15, I want the rate of change at 15 hours. Can I pull that from the chart? No, but it did say an approximation. No. So it's between 12 and 16. But if I have to actually find a value, an approximate value, what is another word for rate of change? Instantaneous. It's slope, right? So let's think about a curve. So I'm just gonna draw a parabola, right? So remember, your tangent looks like this, yes? And we want it right at that point. If I can't find it at that point, could I do a secant line and get an approximation? right? So I want the secant line with it on, really on either side. That was kind of a bad picture, but instead, let's say my tangent is like right here. So I want the tangent at that time. This is not at all what the graph looks like. I'm just using this. But I can't, no, it does. But I can't find this because it's not there, but I can use these 2 points, and that would be an approximation of that slope. Does that make sense to you? So we can use 12 and 16. We're getting to IVT. This is not IVT. This is your average rate of change. Okay? So listen, here's how you know what to do. This is what's important, so you know what to do when I'm not working these with you. You're looking, if it tells you approximation, you're probably going to have to do an average rate of change. And think about what you want. I want the slope. You know how to find slope, right? So we're going to say W of 15, W prime of 15 is about, it's an approximation, so it's not an equals. It's a squiggly. It's an approximation. That would be W of 16 minus W of 12 over 16 minus 12. F of x minus f of x. Y minus y over x minus x. That's all that is. Yes. And so then W of 16 is 294 minus 257 over 4. Okay. So this, number-wise, we could stop there. We can't stop here. We could stop here. And we're going to go ahead and just finish the fraction up a little bit. But this is going to give us 37 over 4. But what you can't forget are, it says use appropriate units. So this is gallons per hour. Per hour. Yeah, I mean, that's basically what that is, if you think about it. It's still just a fraction, but yeah. Okay, so then it says, interprets the meaning of your answer. So we're going to say, at t equals 15 hours, right? Now, does this tell us how much water is in the tank? No, it tells us the rate at which what's happening. Mm-hmm. So at t equals 15 hours, water is flowing into the tank. I'm just using the words from the question. Flowing into the tank. Yes, very careful with that, though. We got to add an extra word. Can't speak. Flowing into the tank at an approximate, yes, an approximate rate. Yes. If you say it's at that rate, you are wrong. I would at least do the ROX. You know what I mean? Because APP could be a lot of things. Maybe nothing that makes sense in this context, but you want to make sure that they really understand that you know what you're saying. So, at an approximate rate of 37 gallons per hour. Oh, okay. 37 gallons, I'm sorry. I was going to say per every 4 hours. 37, I changed my sentence in the middle of my thought. 37 over 4 gallons per hour, yes. BS, yes, you have to be S for sure. Be specific. I was going to say 37 gallons every 4 hours, which is a correct thing too, but then I changed my thought in the middle of my thought, which is never a good thing to do. All right, how are we doing? We good? I don't know. Okay, so now it says, use the data in the table to find the average rate of change. It straight up tells me to pay attention. Straight up tells me to find the average rate of change. That means I'm going to find slope over the time period from 4 to 20 hours. Okay? So your average, and it just says show the computations. So my average rate of change from 4 to 20 is going to be W of 20 minus W of 4 over 20 minus 4. Okay. No, you show where it's coming from. So then this is equal to 327 minus 184 over 16. And then if we want to stop here, we can stop here. You can leave the denominator as 20 minus 4. It's fine. But we're going to stop here, and then we're going to say this is gallons per hour. You can do that. It's a safe stop because they're not checking your computation, checking if you understand what's going on. Do I need to do anything else to this one? No, it says show the computations. That's why you have to show the computations. That's fine. Okay. We all good on that? Everybody good on that? All right, so on D, it says for t between 0 and 24, must there be a time t when the tank contains 265 gallons of water? Justify your answer. Yes, because IVT. But is that all we have to say? Or we have to say more? We have to say more. Yes. All right. So how do we know we're allowed to use IVT? What do we have to have? What has to be true about the function? Has to be continuous. How do we know that this one is continuous? Exactly. Okay, so we say, since W of t is differentiable, you do your best. Differentiable. Yes, well, and they are, but they're also math teachers. You got to think about that. Are they going to really be butthurt if they can't spell it? It's fine, as long as you know what you're doing. Since WT is differentiable, it is also continuous. So remember, you have to say it's continuous, and you have to say how you know. Okay? So, since it's differentiable, it's also continuous. She did. And since, all right, it's okay. I'm a math teacher. 265, where does that fit in here? Well, actually, it's asking between 0 and 24. So you can do it over the whole thing, but you can also narrow it down some, right? So where does this fit? 12 to 16, it fits in here as well, right? So we can do it from 12 to 16, but it's asking about 0 to 24, so I can say that's fine. My lowest number of gallons is 150. That's less than 265, which is less than 357, right? Okay, so since that number falls in between those two, right, there must be a time t for, okay, here's the thing. You have to show this interval, and you have to restate this one. Okay, like we don't know what the time is, but there has to be one. And then we have to restate when the tank, let's see, contains 265 gallons of water. How do we know this? By IVT. Cat. What questions you got? Okay, so we have 2 more examples to do. Hang on, I want to give you this at least in case, you know, you're like Lorenzo and have a few dentist appointments every week. This is the assignment. You can at least get started on it. It's not hole punch. I know, I'm sorry. Hang on to it. I'm meant to do the stack, and I'll hole punch them for you tomorrow. All right, have a great day. Take that with you.